In this video, we will learn about the two main layers of our atmosphere. The troposphere, full of weather and bad ozone, and above that the stratosphere, where good ozone protects us against dangerous ultraviolet light. Our atmosphere is made up of gases, mostly nitrogen and oxygen. They are held to the Earth by gravity, a sort of ocean of air. Because air is compressible, it gets less and less dense as you get further from the Earth. Let's consider the first 50 kilometers where 99% of the atmosphere is found. Visible sunlight passes through the atmosphere and warms the ground, heating up the air at ground level. As the colder air above sinks, it pushes up the warmed air, which is less dense due to expansion. This movement, known as convection current, gives us our weather systems. The atmosphere gets colder and colder till you reach about 10 kilometers, the tropopause, where the temperature is coldest. Below this is the troposphere, containing 80% of our air, and all the weather. Above the tropopause we have the stratosphere. This is a layer of thin air which is hot on top because it's heated from above by ultraviolet radiation absorbed by the good ozone and cold underneath, making it dynamically stable. Contrast this with the turbulent troposphere. If you have ever flown in a jet aeroplane, you may have had a bumpy ride after takeoff through the turbulent troposphere, but once you're above the clouds, above the weather, your journey is smooth. Propeller planes cannot fly this high because the air is too thin for the propeller to grip the air. So where does this good stratospheric ozone come from? Pause the video and think of the formula of ozone. Well, ozone is an allotrope of oxygen. Its molecules are made of 3 oxygen atoms bonded weakly together. It is an unstable gas which slowly decomposes back to molecular oxygen. The ozone in the stratosphere is continually being made and broken by the ultraviolet light in the ozone-oxygen cycle. To start with, UV gets absorbed in the stratosphere by molecular oxygen, which splits into 2 fast-moving atoms. These fast-moving oxygen atoms collide with air molecules around them, nitrogen and oxygen. This slows the free oxygen atoms down, enabling them to bond weakly with the molecular oxygen to form ozone. If they're moving too fast, they simply bounce off. The energy they shared with the molecules in the air heats up the upper atmosphere. The oxygen atom has now joined with an oxygen molecule to form ozone. Ozone is very effective at absorbing ultraviolet light, which causes the ozone to split back into an oxygen atom and an oxygen molecule again, keeping the upper atmosphere warm. Ozone reforms as before once the oxygen atom is moving slowly again. The ozone is spread out through the stratosphere, shown here in black. Why do you think there is so little ozone high up and low down? Remember, we need ultraviolet radiation and oxygen to make ozone. Pause and think. Well, here there is too little oxygen, and here, near the tropopause, the point of lowest temperature where the troposphere and the stratosphere join, there is no ultraviolet light available. It has all been absorbed by the ozone further out. So this is the ozone layer. If the ozone were squashed together like a solid, it would only be the thickness of a sheet of cardboard, but it is actually a gas spread out over 20 or 30 kilometers. Before our atmosphere was filled with oxygen, the UV reached the Earth's surface and prevented life from emerging onto the land. Ozone is also present in the troposphere, formed mainly by the action of sunlight on pollution from motor vehicles. Here it helps to form photochemical smog and is a pollutant.